Good afternoon, everybody. I'm Binisha. I'm from Technology Development Board. On behalf of all the organizers here, let me welcome all of you to this event on sewage, septage, and sludge management in small towns and villages. I-Connect programs specifically is mainly to connect between the industry and the scientific community, so that there are specific projects which have been or the topics which have been chosen, and this is because of the Azadi Ka Amrit Mahotsav, because 75th year of Indian independence. Under this program, the DST, that's the Department of Science and Technology of the Ministry of Science and Technology, has initiated this program, wherein most of the programs are online and some of them also as hybrid, to bring in this connection so that the industry can pose their problems, and which the scientific community can take it forward and start with research, or even if they already have certain research projects which are ready to be deployed on ground, then this kind of a match making is what is thought of by the government through this program. Otherwise, if there are any new ideas, it is that because this program is open to also colleges and other entrepreneurs who are interested in starting an industry, that is like for the startups, this could be as like an idea. So the programs which have been chosen, the topics which have been chosen, are all which are having some social relevance. Here in TDP, this series of programs are on waste management. So yesterday we had one on single-use plastic, and today we are having on sewage, septage, and sludge management, which is again an important issue. So welcome all of you, and I welcome all the dignitaries. They will also be introduced by ATREE, which is hosting this program. We have other partners like Ecoparadigm, and of course the ministry and TDP. And the keynote address will be given by Dr. Chaurasia, who needs no introduction. Welcome you, sir. And I welcome all the other speakers to this event. So with that, let me just channelize the thoughts and set the agenda for today. First of all, to look at the Indian scenario, we have about 4,000 odd ULBs in India, and this is as per the 2011 census. So we have a little more than that, and we have about 5.8 lakh PRIs, that's the Panchayati Raj institutes, and which very clearly says that all these are the agencies which actually anchor the sewage management or the STPs. Now, India has about 816 STPs, out of which only 522 are operational. Now, if you look at this, which means at least every ULB should have had one STP, which means we are really running short, or we don't have that many of sewage treatment plants. And this itself clearly says that we really need to do a lot in this sector. Now, treatment of the sewage in all these PRIs is also almost like nil, whereas in ULBs we have a few of them which are also having the underground drainage systems which is connected. Now, India generates about 73,000 MLD sewage, of which about 32,000 MLD undergoes primary treatment and the rest is untreated. So this is actually the grave situation of this issue. But however, thanks to Swachh Bharat mission, people have got access to toilets. There is also, I mean, not just ensuring privacy and dignity, but we have also been able to decrease the open defecation. And a lot of the sewage has been contained in the twin pits. So that's the scenario. Now let's come to the problem statement. The individual and also the community toilets, in the absence of the UGD networks, which is actually currently, traditionally, it is connected to the single and twin leach pit, and or sometimes to septic tanks. But even with that, only 20 to 30% of treatment actually happens in these septic tanks. That even that also, if it is maintained scientifically as per the relevant IS standards. Now, after all this, the desludging should be taken up once in 2 years, and this sludge again needs to be handled scientifically. So these are the issues here. The Swachh Bharat toilets have been completed now successfully. There are many of them, but they're all now in the stage where it has to be desludged. So this is something which is staring at us. And we have improper sludge management, which also will lead to impact on the soil and water, that all of us know. And this is actually, there are also cases where we have seen that some of the borewells have been contaminated in the villages. And there are also many instances where it is only drinking water in the entire village, and that also is also contaminated with fecal coliforms. So the one of the solution is to set up FSMs, that is fecal sludge management, or fecal sludge treatment plants, which has also been initiated. And you can, as you can see in this picture here, this is in Andhra Pradesh. So which needs a lot of investment. And even for one plant which can handle one vacuum truck which removes the sludge, that itself costs about 60 lakh rupees to even 1 crore. So investment again for all these kind of sludge treatment is again another issue. Now, what is the approach? The ideal situation could be in all the sewage. That is, if all the sewage is collected and conveyed by sewer lines to the sewage treatment plants, with or even a few decentralized system, this can solve the issue. But we should remember that STPs can be built quickly. However, all these sewer lines or the sewer line networks, that takes a long time. And you know, for 6 lakh towns and villages in India to start having this sewer networks and to install permanent scientific solution and to also have treatment plants, it will really take a long time. To tackle this pollution, we also need a quick solution, that all of us know. But fecal sludge treatment plants can be set up. That's only a temporary solution. But it is again, as I mentioned to you, it is very expensive. Now, one probable solution could be that we can have this temporary solution of FSTPs, but they could be designed in such a way that it can form part of the future STPs, so that the investment could be salvaged to some extent. And decentralized treatment systems definitely is a good solution, but too many of them will also become very difficult to monitor, because the pollution control board will not have that kind of bandwidth to check every decentralized solution. So we need to find some good solutions which can tackle the immediate problem and also in future. So for that, today we are having many experts. We will listen from them and then come out with a plan for the country to treat all our waste. So with that, I open the floor to the experts speaking. So thank you. Over to Shreya.
Thank you so much for setting the context, Vinisha. It's very clear what the problem is. I would like to invite Dr. V.K. Chaurasia to give us his perspective on this. He's the Joint Advisor to the Central Public Health and Environmental Engineering Organization and holds a PhD from IIT Delhi and has over 20 years of experience in this sector. Over to you, Dr. Chaurasia.
Yeah, uh, good afternoon, Sneha. Very good afternoon to everybody. And I am very glad to see Majumdar sir. He is present. He has been guiding us a lot and for quite some time because of, I think, COVID and other, we were not able to interact too frequently. So now I think that trend is going to start and collaboratively we will work for society. That's good thing. I even thank Pravinjit also to remembering me and giving this opportunity because this subject is very close to my heart and we are working on it very intensively. So I find it is a very, very pertinent and relevant topic that how to address this used water management problem or sewage problem in smaller towns, especially sewage, fecal sludge management, and even septage, what all these things are there. I find sometimes a lot of confusion exists and there is lack of clarity that what to do and what we are going to do, what result it will give, especially in case of treatment. So because of this, it is happening that whatever somebody else is doing, people are also following, and those people who are going and propagating, they sometimes themselves also don't know what actually they are doing because they have seen somewhere they are in the market and they are doing business, so they are going and advising others ki you do like that. This sort of one circle is created which we sitting here and discussing with various experts in the field, we find that it is taking to a direction where immediate correction is needed so that whatever effort we are putting, investment we are putting, and objective we want to address, that is properly addressed in coming years. So I could see Miss Benissa, she very well set the context, and from that I could definitely get the feel that sensitivity is there, that used water should be treated even in small towns, villages also. This is one thing that Government of India for first time they have brought in their policy, that we will take right up to village level, and under Swachh Bharat Mission Gramin, there are components, even they are providing funding support for treating even used water in villages. This thing some 5 year back, 3 year back, it was beyond our imagination. People were only thinking that even in larger city, if it is addressed, more than enough. But now government has come out with this policy that not only a smaller town, but even villages also, they can aspire, and funding and technological support is available to help properly manage their used water as well as septage. So for this, as I mentioned, this Amrut scheme and SBM scheme both are having even up to 50% of funding available to manage that. And in addition to that, another thing, because you people will really connected to the people who work on the ground. So in respect of funding, I would like to mention that only these two missions are not there to fund. Even 15 Finance Commission grants equal to what Swachh Bharat Mission is providing, equal amount of funds are available there also. So if these things are channelized, we have worked out that Government of India is providing something close to 65 to 70% of funding support needed for a city to implement what Ms. Benissa mentioned, that ideal are very well recognized sewer network along with STP and other, which is really the desired in long term. And this is the single thing that is across the all developed countries that is followed. So this is one thing regarding the constraint we have been thinking that where funding is available. Second thing that comes very important is that how to develop a positivity, or let us say our ULBs and all those who are involved in this, they also feel okay, this is important and we should strive to get it done in affordable cost and go ahead with that. Uh, Many people I sitting here in ministry, I speak and I find even at senior level, even in government functionary, their thinking is that okay, let sewer network and this sewage treatment, it should be only for class 1 city or million plus city, smaller city not a problem, because this indicates we are so much into it, stressing that in case of smaller towns also, unless we make a beginning, the problem when we take at later stage, it will be compounded. And when we start these sewer networks, sewage treatment, pumping and other thing in larger cities, there is already paucity of land, already lot of business activities are there. When we are going to start this activity, even road cutting, laying pipeline and all other thing, it create lot of inconvenience and lot of complaints are there, because of the project takes 6 year, 8 year, and lot of negativity is there about the sector. So if we start from early stage, let us say class 2 town, class 3 town, so there will be a behavior change in the people also, especially regarding this sensitization to wastewater management. Right now, as I mentioned, many senior people think what is needed in the smaller town, let us focus on larger city, because problem is so much complex and compounded that they don't recognize it at all. So what I want to stress that in given scenario, government of India has taken cognizance of it and they are supporting all out all those stakeholders like we are connected today. And this was my purpose also to come to you, that let us in capacity wherever we are there, whatever impact we can put, let us sensitize and plan from the beginning what government of India support is providing. And second thing I would like to emphasize, that often there has been tendency that when we are planning, let us say sewage network and other, often we take centralize and whatever the most costliest, we think that is the best solution. That is not the best solution. Best solution always depend on which situation, which type of condition and whom we are providing. For a smaller ULB where agricultural fields are there all around, even that medium level affordable technology like waste stabilization pond, even trickling filter, or even constructed wetland, all these things are more than sufficient. All these varieties are more than sufficient. Everywhere, this thing that we go for SBR, MBR or MBBR, this is not only the solution. If we do, what will be the problem? It is going to give bad name to sector. Why bad name? Because in few project lot of money will be spent, and when money is spent in construction, the time comes for operation and maintenance where ULB don't have finances to even operate it, run it, and so that will be standing as a monument and people will. This is reason that to select seriously so that the intended objective is achieved. One confusion is that no, standard is less than 10 BOD, less than 10 TSS and all these things. How to achieve that? I would like to make it very clear that earlier it was 1986 rules where BOD was 30, TSS was 100 and COD 150 and like that. But later on in 2017, uh, this revised notification came from Ministry of Environment Forest. That was somewhere through NGT, it was stayed, and after hearing in Honorable NGT directed that MOEFCC should come out with a fresh notification where stringent norms as is suggested should be there. But there is a process for notification. What NGT suggested is not valid and implementable as it is. They directed that let it be notified. So rather than notifying, Ministry of Environment Forest understood and they consulted all the stakeholder ministries and they found that whatever is there, treatment should be need-based everywhere. 10 BOD, 10 TSS and other somehow may not be workable, and it will definitely drain out a lot of funds available with ULB, and whatever objective we require, this solution will be very costly. So they went, MOEFCC went in appeal to Honorable Supreme Court. That matter is pending. I think in 19th it is going to come. So what I want to emphasize at this stage, that once Honorable NGT stated that 2017 notification, the earlier existing 9086 is still prevailing. So BOD 30, TSS 100 and other thing we have to follow. Many places may either industry people or even sometimes state pollution control board people, they sometimes emphasize and they insist you go for that. That, as I mentioned, it will drain out resources. We have to be clear about us, it, and guide our ULB accordingly. This will help us to give a number of technological options available. If we restrict to 10, then only 2-3 technology will come, and that will become affordable. Then this dream for all smaller town, villages, other things, they will be left out. This is not. We have to be very much, I think, considered view we have to keep, where why we are going to do, what is the level of treatment needed, and which are all technology that will be providing that level of treatment, and end product or end effluent, how we are going to utilize. All these things we have to keep in mind, and accordingly our system we have to plan. But next thing I would like to say in this case, that apart from standard, the challenges often people feel that there are challenges related to land and similar sort of things they used to find. Sometimes fund, as I mentioned, technology, land, other thing. Land ke case mein I would like to mention there are several options available. Only some level of discipline is required in operation and maintenance. We often on our part don't manage enough discipline, and we blame on technology is failed, and we go for very high-end technology and we are not able to run it. So such type of thing we should not follow, where we are because of lack of application of mind, because of lack of awareness and technological solution, our ULBs are suffering and we are going in a mess. To address that only, we have prepared one ready reckoner that will be equally good for even administrator, even all stakeholders, whether they are engineers or not. We have brought out in form of a fact sheet about each technology, that what is its cost, what is its suitability, what is the process in very simple terms so that anybody can understand, O&M, and where it is more suitable, what is land requirement, all those things, along with layout plan. Pravinjit and their team has helped a lot in preparing all those things. So pictorially we have given a lot of things so that people can feel. Only writing and very big manual sometimes only designer use and intellectual and professors use. But in this case we are trying very restlessly, I will see, that each ULB, whether they are small or big, and even sanitary inspector, they should also understand that what is this technology, how it is working. Then they will be able to monitor, and then they will be able to get the result. Otherwise it is left to some PhD engineers, and whatever they are doing, others are there only to sanction and sign and send that. So this is one thing where we are intervening very I will say intensively. And the last point I would like to mention, that I came in this technology development board meeting with intention that ministry is helping, and they are now very conscious to promote innovations and explore wherever ideas, like Ms. Binisha mentioned, that we are exploring technically supporting. The same thing we are also doing. We have floated for technology challenge, some more than 120 some entries are there. Out of that, 30 we have shortlisted. In case of 10, we are going to pay 25 lakh also. And apart from that, even that AFD French company, they are also going to 1 year provide incubation. So I was exploring before this meeting only with you that how we can now collaborate, because alone doing in isolation and silo things will not help. All those stakeholders, they have to join hand, and what you are doing, what we are doing, all these things go so that we can have a proper spread of information and these things. So in case of innovation, whatever you people are doing, that thrust should continue. Let us sometime discuss with ministry. We will provide one opportunity and see that how we can collaborate, and we can come out with more and more innovative solutions, so that cost cutting is there, efficiency is there, operational simplicity is there. Unless these things are there, our 4,000 B and around 5 lakh villages, they will be kept away from it, and this all sewage management and other thing will be limited to only few corporations. So with this, I would like to thank very much to Technology Development Board for inviting me, and we will be very much glad to help and join hand to work a sustainable solution in this direction. And whatever findings and requirements emerge out of these days discussion, please share with us. We will also try to see that how we can join with it, how we can help, and how we can take it forward. Thank you very much everybody. Again, Dr. Majumdar ji ko, Pravinjit ji ko, Vinisha ji ko, everybody ko mera namaskar. Thank you.
Thank you so much, Dr. Chaurasia. Thank you for explaining all of the issues with standards and the challenges one faces, and how we can bring together both knowledge and government partners to make a change on the ground. I noticed that Colonel Rakesh Jain is here. So if you wouldn't mind, Rajesh Jain, would you please give us the welcome address, if that's okay?
Thank you very much. I mean, there were some technology issues as well as the Technology Development Board, and as well as there was no electricity. Actually, I was trying to join with my mobile, but I was unable to do that. Anyway, I'm representing Technology Development Board, which is an autonomous body of Ministry of Science and Technology. I am filling in shoes of Shri Rajesh Pathakji, who is secretary. Presently, is on leave, so another Rajesh Jain is joining instead. So good afternoon to you all. Sorry for this delay, etc. I should have been prepared much earlier, but nonetheless, this is in series to celebrate and commemorate 75 years of Progressive India. Ministry of Science and Technology is celebrating Azadi Ka Amrit Mahotsav by conducting 75 S&T events. These programs are aimed at industrial connect and participation by industry, etc. I welcome you once again to all of you for the sewage, septage, and fecal sludge management technologies for towns and villages in India. It's a very interesting topic, I mean, by itself, which is aimed at knowledge sharing, entrepreneurship, and skill development in the domain of waste management. We already have given a call for waste management. I mean, just finished on the 10th of July. It's my pleasure. All of us, anyway, we all of us know each other. Ms. P. Vinisha ma'am, who is environmental scientist, board member of the Technology Development Board for 4th consecutive year. Shri Chaurasia ji, senior advisor, Ministry of Housing and Urban Affairs, Government of India. Dr. Joy Ilamohan, Director General, Kerala Institute of Local Administration. Dr. Priyanka Jamwal, fellow, if at all, I hope everybody is there, Water and Soil Lab, ATREE. Shri Manish Chaudhary, who will be telling you about in detail and giving a small presentation from Technology Development Board side, Scientist D at Technology Development Board. Pravijit KP, MD of Ecoparadigm. I saw his, and Dr. Pravita Dattade, Head Water and Waste, National Institute of Urban Affairs. And lastly, Dr. N.B. Majumdar, Chairman of International Academy of Environmental Sanitation and Public Health. We all distinguished guests, participants, everybody. I hope everybody have logged in also of Science and Technology and Innovation. I'm confident after this webinar, we'll all have new ideas, lots of fresh energy. It was a very interesting talk which I heard from Dr. Chaurasia. I was all attention and all focus. It was very interesting ideas which he was bringing. We'll have partnerships to sustain our efforts, and we would all stakeholders will develop some technologies and harmonize them so that whatever we see here in India, the technology is unable to deliver, or our approach in managing the organizations remains rather weak and negligent, and we blame the technology at the end. I think simple technologies work better. As one can see, I stay here in Faridabad, I see while coming, this is the biggest issue in Swachh Bharat. This is the biggest issue in Swachh Bharat. With this, I once again welcome everyone, and sorry for being late, whatever may be the issue, and welcome once again. Thank you.
Thank you so much, Colonel Rakesh Jain, Rajesh Jain, sorry. For those of you who missed the introduction, Colonel Rajesh has over 33 years of experience in the Army. He's worked at various levels, mostly in administration and technical and financial domains, and he's the director of the Technology Development Board. I would like to now introduce our second keynote speaker. Today we'll have Dr. Anil Kaliat instead of Dr. Joy Elamon, because unfortunately Dr. Joy is unwell. Dr. Anil Kaliat is the Urban Chair Professor at the Kerala Institute of Local Administration. He's a geographer and an urban planner with 21 years of experience in planning and researching cities and their sustainability challenges. As a trained researcher, his interests are related to two of the futuristic ideas of sustainability and entrepreneurship. His focus is on application of knowledge for social progress, and he's trained to use creative processes to engage and influence for integrating sustainability and entrepreneurship into organizational practices. Over to you, Dr. Anil Kaliat.
Thank you. Thank you for the warm introduction, and thanks, Pravinjit, for inviting me. And he was trying to ensure that there is some participation from Kila, because we are confronted with a lot of challenges related to these issues, septage, sewage, as well as FSM issues. And as a rapidly urbanizing society, Kerala is trying to address these problems, and it's a great opportunity to be here to learn and also unlearn certain biases that we have been probably carrying. So unfortunately, the Director General couldn't join because he had some health issues. So I am trying to step in and do justice to that role. The context that I'm going to use is the Kerala context, primarily because that's something which I think the audience would be interested to know, what is happening in Kerala and what are the approaches Kerala is trying to do in terms of managing this issue. So as most of you know, we were 47 to 48% urbanized in 2011, according to the census. That to about 4 districts were about 65% urbanized. So the kind of trends in urbanization is what has been offering new conflicts and challenges to us, because we were suddenly we realized we are more urban than rural or semi-urban. So the society's aspirations, also the behavioral responses to certain conflicts obviously needed to be molded accordingly. So we are now trying to catch up with this reality. So by seeing the numbers, and also high density of population, so about 852 people per square kilometer is what Kerala's population density, which is quite high. And then we don't have a real difference between urban and rural, because it's a continuum. The urban pattern is also quite challenging in terms of managing different resources and also services. So the heavy rains we receive again adds to the complexity of our issues. So within all this challenge, we have not really succeeded in establishing a very robust system of septage, sewage, and FSM management. What we have so far got is about 6 plants, which are primarily in Cochin as well as Thiruvananthapuram Corporation, and then one in Guruvayur as well as one in Kalpetta and Wayanad district. These are the 6 operational plants, STPs, which we have, and another 8 are at different stages. Sorry, another 14 are at different stages of development. So considering that 93 urban local governments we have, and also we have about 461 census towns, this is a very small number. So that itself will explain you the kind of problem that we are staring at. And we are still kind of trying to address this gamut of issues. Should we start with IEC? Should we do it? Should we work towards behavioral change? Should we bring in technology? Should we have any other way of addressing. So there are different conflicts and deliberations happening, and the state is trying to innovate in different ways. And there is a reasonably good institutional ecosystem which the state has established, the Clean Kerala Company. Then there is this state pollution control obviously has been trying to do its best, but also Shujitva Mission. And to address the issues related to solid waste separately, there's a major multi-year funded program coming from the World Bank, which hopefully is going to reduce the burden, because a lot of this waste, solid waste getting dumped in the water bodies also adding to the problem. So all these things, along with the central and state finance commissions, tied grants, focusing on the urban agglomeration, there are resources available, financial as well as institutional as well as policy resources are available. We had a state sanitation strategy in 2017, which was done in follow-up to the 2008 National Urban Sanitation Policy. So state has tried to address these issues, but the way the state has urbanized, as well as the kind of patterns of human habitation having changed rapidly, we haven't been able to really solve the problem. But there are all intentions, and parallelly we also try to equip the local governments, both urban and rural, by showcasing different technologies as well as solutions available around within the country as well as wherever it's possible. Also nudge them to kind of look at ways in which they could give greater cleanliness to the community. So there are community level awareness, participation. IEC campaigns parallelly are happening. One of the most recent thing which has helped the state to kind of put this into the forefront of state civil society discourse is the Clean Kerala campaign. Clean Aquifer campaign. So where the local self-government department, which is a converging point of both urban and rural, the local governments have kind of done a survey of about 40,000 water bodies and mapped them to see what kind of waste get dumped and the quantity of the waste which is getting dumped in these water bodies. And now the maps are getting curated. Soon we will be able to kind of take very strategic place specific actions. So still being up and high in the agenda of both the state and local governments, we haven't been able to kind of say that we are a society which has established wise strategies to address our waste problem. But eventually, with all these interventions and in a concerted manner, hopefully in the next 2-3 years, Kerala will have greater models, again decentralized, which are, some of them will be community based, some of them will be in smaller and medium towns, which is also the point that getting deliberated today. So the way forward for us is much more behaviorally informed change, much more community owned change, and also bring a dose of technology wherever it is required. So that's the way I think we are going to go forward. And I think at this point, I will just wind my bit of intervention. Thank you. Thank you for inviting me.
Thank you so much, Dr. Ajit. It was really interesting looking at the fact that one needs to also take into account solid waste management. And it's very interesting to see how Kerala is prioritizing both behavior and community in addition to technology. I would like to introduce our first technical speaker, who's a colleague of mine from ATREE. Dr. Priyanka Jamwal holds a PhD from IIT Delhi and is a permanent faculty at ATREE since 2012. She works at the interface of science, policy, and practice, and is interested in identifying newer focus areas that can lead to effective policy making. Her interest lies in understanding the fate and transport of contaminants in hydrological systems. In addition, she is also interested in understanding factors responsible for the sustainability of nature-based solutions. So far, her work on understanding the risk to public health on exposure to contaminants by wastewater use in irrigation has influenced the surface water quality monitoring framework in the catchment area of the Vishwabharati River in Karnataka. She closely works with all states and non-state actors, formal and non-formal, to identify the interdisciplinary nature of problems and develop solutions suitable to local conditions. Over to you, Priyanka. Priyanka?
Okay, am I audible?
Yes,
Now?
yes.
I'm very sorry. Yes, I just forgot to unmute myself. So thank you so much for the introduction, Shreya. And can you see my screen?
Yes, we can see your screen.
Okay, let me just, I'm just saying share screen, and I'm going to Windows, and I'm just, yeah. It's okay. Then let us just don't waste the time and just go ahead with the presentation. So now you can see, but it's in the slide mode, right?
That's right.
Okay. Okay, so as the previous speaker were talking about, decentralized technologies. So let me just quickly, so Shreya has already introduced me, but let me just tell you exactly, so I'm a civil engineer and I did my PhD in environmental engineering and management. And actually, I really work on addressing water quality issues, both looking at the policy angle and also as well as the technology angle. So given the audience today, I thought that it would be more appropriate to talk about the solutions and talk about decentralized technologies and draw upon my work, which we have already done in rural areas as well as in urban areas, and just give you a gist of how we have implemented the technologies, low cost technologies in both the landscapes. So again, I'll not take much time on this slide, but just want to tell you that we work on my work basically focus on addressing clean water and sanitation issues. And if you look at the targets of these issues, I think clean water and sanitation is basically says that access to safe drinking water and affordable drinking water by 2030. And the second, the most important target is to improve water quality by reducing pollution, eliminate dumping, and minimizing release of hazardous chemicals. And the third one, which was given very much importance, is participation of local communities, because what we have also observed from our field work is that none of the projects get successful unless and until the local communities are involved since during the beginning of the project. And it's not that you finish the project and in the end you just disseminate the results. So I will give you an
Priyanka?
example of, yeah.
Sorry to interrupt, but if you're changing slides, we're unable to see that.
Oh gosh,
Yeah, I think this is good. If you can just go down the way that.
Okay. I'm extremely sorry. So I'll just start from the case studies. So we have deployed the wastewater integrated wastewater treatment system at one of the school in Berambadi, which is a small village near Mysore. So so you can see the location of the village and the school. So school had around 210 children, and the objective of this work was to improve the environmental sustainability, to reduce the dependence on freshwater resources of the school, and to make sure that the grey water and the black water at the school level is treated. So when we did the initial baseline survey, we found that the black water was leaching and it was contaminating the hand pump sources which were close to the school, and the grey water was also having a lot of issues because the grey water was directly being discharged on the open in the place where the children used to play. So again the same thing, so it was basically, the project was collaboration between various institutions. ISC was the part of this particular work, and the environmental benefits we were looking at was improving groundwater quality, end of open defecation, and reduce water and waste and energy consumption. So we started with doing the baseline study because baseline is very important. And I pay a lot of attention while doing the baseline, because if we want to assess the impact of intervention, it is very important to see what was the baseline scenario before the intervention was implemented. Again, it also provides the evidence to the policymakers that, okay, these solutions work, because most of the time I've seen that there are certain NGOs, some NGOs and some implementation institutions which will just take the solution, and without thoughtful design, they will just put the intervention in the field, and then we realize that there is no evidence, there is no data to show whether those interventions work, and as a result, the scaling of intervention doesn't happen. So one of the things for doing baseline is also it promotes scaling up of the interventions, because you have scientific data to show that these interventions work or not work, what are the challenges. So we carried out this baseline. You can see I have a water quality lab here, world-class water quality lab here, where we pick up samples. We do some water quality testing on site, and the samples are also brought back where to the lab where the testing is done. So you can see that in this particular school, there were 3 streams of water which were coming: hand wash water, kitchen water, and black water, and the solution was provided to all these 3 streams. Now, this I don't want to go through the slide, but basically it shows the kind of parameters we had tested for each of the water stream, and so these slides also shows the quality of baseline data. So we picked up water from all these 3 streams, and based on what the contaminant load we were
Priyanka,
getting.
sorry,
Yeah.
we can't see your screen. Yeah.
Oh my God, Shreya, and I'm extremely sorry, but it's just like, I have not.
Do you want to?
Can you see it
Yeah.
now?
Yes, now we can see it. Yes.
But at what slide did it disappeared?
I
Did you
think.
see any of the slides?
Yeah, but I think it's okay. You can continue from where you've told, so you can go to that slide. Otherwise,
I'm extremely sorry, but I don't know. I've
That's
never,
okay.
with WebEx, I'm facing a lot of issues. Okay, so I
Yeah.
will quickly show you what we have done. You can see this slide, right? For the hand
Yeah.
wash, what we have done, we have created a 3. So we did a very thorough baseline where we estimated the flows, what is the total flow we are dealing with, and what is the contaminant load we are dealing with, and that guided us that what should be the size of the filter media, how long should be the retention time, because these are some of the minute details which people don't, or which the implementation agencies don't think through. They just take the standard design and they just replicate it everywhere without doing a thorough baseline. So we did a proper baseline, and you can see that these technologies were deployed at the school, and what we found was, I'll just go to the key findings, that the organic load removal, which is the organic matter reduction, was 94%, fecal coliform reduction was 6 log orders, and we got effluent which was with BOD levels less than 10 milligrams per liter, which is basically urban reuse standard. So we are saying with the basic technology of filtration, which was guided by thorough baseline, we were able to put this technology. And for the black water, what we did was we provided septic tanks with constructed wetlands. So here you can see that we have these constructed wetlands, and because it was a research project, so we were testing the efficacy of plants. So you can see that the one side of constructed wetland is with plants, and another one is just with the filter media. And we tested these 2 systems, and we found that there was no significant difference in the kind of treatment these both systems with plant and without plant was providing. And this paper, the study has already been published, and this has a very important implication in operation and maintenance of these systems, because when we have plants, we need to invest more on operation and maintenance of these systems. So we found that, even without plant, we are able to meet the discharge standards, environmental discharge standards. So if you look at the overall, we found that there was 54% reduction in water consumption, and we also looked at the one more thing I wanted to tell was that the grey water which was treated was reused for flushing the toilets, which was further treated in constructed wetlands. So it really helped us in reducing 54% dependence on freshwater resources, and the school was also provided with solar panels, which further helped in reduction of 50% power consumption. And as I mentioned initially, that community engagement was the key when we started this project. So even the school children were engaged while we were designing the toilets and septic and constructed wetlands, because they are the one, once we leave the project, the community is the one who is going to take care of these projects. So it was very important for us to community engagement. Now coming to the urban case study, where so you can see, like, it's nothing which people, it's not that something we don't know, that our urban drains, and if you go to small towns, the drains are filled with gray water, sometimes mix of black and gray water. So this is the state of our current drains. And then what happens, this water enters into our lakes, our water bodies, and then we see fires and dead fish floating on the lakes. And then downstream we see the same water being used for irrigation. And we have done another separate study where we found that the heavy metals and all accumulates and it comes back on our plate in form of food. So then what do we do? So what we have, like, so generally what happened when we have these kind of situation, we always think of these top-down responses from the government, where they say that, okay, let us build another large wastewater treatment plant. But as the first speaker was telling, that laying underground drainage network take a lot of time. So you put a wastewater treatment plant, but by the time it functions, the population again increases with 1 million, and always there is a gap, and always you see gray water flowing, mix of gray water and black water flowing in the stream. So what do? Do we have some water bottom-up responses which can help which are inexpensive, scalable, effective, and flexible, and which can address water quality issues? So we did this small pilot in one of the lakes in Bangalore, where we said that, okay, these stormwater drains, because the space is limited, so these stormwater drains can act as a treatment systems themselves. Where what we took a case of Salkere, which is one of the lakes in Bangalore, and what we did was we tested this system, kind of a filter media, where we diverted a part of inflow into the filter media, and we looked at, so you can see this was the pilot where we tested the different efficiency of different filter material, which is gravel versus terracotta. Again, it's a scientific study, but it has a lot of implementation potential. And this study is also published in one of the reputed journal. And what we found was that these systems are important, very efficient in removing in reducing the BOD and COD levels, and also fecal coliforms. Now, if you want more details on this particular study, I can share my the research publications, and you can take a look on the kind of data we generated. What is the retention time? So what we said was that even with low retention time, like, or the gray water, these systems have enough potential to treat gray water which comes in open stormwater drains. So again, this is the data, and you can see that there is a significant reduction in the COD values. So this, we did a little bit of modeling exercise, and we said that, okay, so again, the idea here is that these in-stream systems, when we talk about streams as a in-stream technology, we are saying that single system will not solve the water quality issue, but we have to strategically place these systems across the catchment to make sure that the water which is entering into the lake is it meets the environmental discharge standards. So so again, for this kind of work, community engagement is very important, because again, we are going to these systems will be managed by the community. So we work very closely with the communities, and especially the lake groups in Bangalore. There are lake groups which seek funding from CSR to run these, to make sure that their lakes are maintained, restored lakes are maintained, and also when certain interventions are done to make sure that the efficiency of intervention is sustained, they seek funds from CSR. So we very closely work with these communities. So again, There are key knowledge and policy gaps, which while I was doing this work, I came across that we need to define discharge standards for grey water treatment. Now you will see that there are a lot of in rural areas, you will see that there will be interventions like put a soak pit. Now those soak pits will be designed based on CPHO manual, which again says that that the soak pits are designed just keeping in mind the effluent discharge standards, right? There is no attention paid on what should be the type, like the design doesn't consider the typology, whether it is a LOL aquifer, whether it's coastal aquifer, whether it is a hard rock aquifer, because that will determine how fast your contaminant move in the aquifer and has a potential to affect the sustainability of our water source, which is bore well or groundwater in most of our rural areas. So these are the key questions which right now I'm working on, where we say that, like, how do different contaminant sources impact groundwater source quality, and what are the other risk factors? It's not just gray water, but also livestock has a potential to contaminate groundwater, which also came from one of the studies which we did in a small town. And another question which we are working on is that what are the appropriate distancing norms between groundwater source and contaminant source. Now you can say that there is a CPHO guideline which says that maximum distance should be 30 meter, between 10 meters to 30 meters, but there is ample amount of research which shows that even beyond 30 meters there is a potential of groundwater getting contaminated through through septic, through soak pits. So then we are saying that what should be the appropriate distance, or what should be the level of treatment at the source itself, so that the quality of our water resources is sustained. So yeah, I think I'm done with my presentation. Thank you. And if you have any question, I'm open for that. And I'm sorry for the glitch that happened. So extremely sorry.
Thank you, Priyanka. Does anyone have any questions? Okay. If not, I think if there are questions later, Priyanka, we can take them down and maybe you can respond to them by.
Sure.
Thank you so much for the presentation, and it was very interesting to see two completely different scenarios, one in a more peri-urban rural setting and one in a setting where a lot of small towns have actually reached the point where they already need decentralized interventions to manage sewage that's previously mismanaged. So it's quite relevant for that as well. And also standards for groundwater recharge seem to be something that are also very pertinent. So it's very interesting to see that that's your focus now. With that, I'd like to move on to the next speaker, who's Mr. Pravanjeet, who's also in some sense a mastermind behind this this talk. He has over 27 years of experience in the field of energy and environment. Pravanjeet is an expert for designing infrastructure projects of various e-waste, sewage, irrigation, rainwater harvesting, renewable energy, and environmental impact assessment related projects. He's been working in various capacities with teams from Germany, the UK, and across the world, actually. And he has spearheaded almost 100 plus environmental projects. And he's the managing director of Ecoparadigm, which I'm hoping that he's going to explain what they do. So over to you, Mr. Pravanjeet.
Thank you, Shreya. Am I audible?
Yes, yes,
Yes.
you are.
Yeah, thank you. Thank you. And my thanks to TDB for sponsoring this program and encouraging us, Ecoparadigm and ATREE, to host this very relevant topic on sewage, septage, and fecal sludge management. I'm also indebted to Dr. Chaurasia and the previous speaker for setting the stage. So Ecoparadigm is a consulting organization primarily. We also do implementation. We are primarily working in the field of wastewater treatment and solid waste management. We have quite few successes.
You should share your presentation.
Yeah, I will. Just a short introduction about our
Yeah.
company. So we were part of the drafting team along with Dr. Majumdar of the Solid Waste Management Manual. And on the wastewater front, we have got several good projects Two of them has received national recognition, one from the Honorable President of India and one the first prize in the National Water Awards. So these are few credentials. So with this, I'll just straight away get into my topic. I think we're already behind time. So is it on slideshow?
Yeah, yes.
Yes, it is.
Yeah. So I'm not dwelling much on this because all this stage and the relevance and the importance have been told. Now, looking at it from an urban local body participant, if I want to manage the wastewater in my city or my town or my village, what are the things which influence me into taking the decision? Mind you, in the latest CPCB report, of this 28 states in the country and the 8 urban local, 8 union territories, only 5 of them have reached some level of sewage treatment plant, sewage treatment in the state as a whole, and that is almost 5 states achieving about 60% treatment. Another 5 about 2026, balance 18 of them and about 7 union territories have got 1 to 2% treatment. So that shows the magnitude of the problem. So, and like Dr. Chaurase rightly said his theme, the current wastewater treatment standard is the Schedule 6 of the EPA, which is 30 BOD, 100 TSS thing. At least that we can always aspire to treat to whatever better treatment we can achieve. But it's a shameful aspect that when we are celebrating the 75th year of Indian independence, we have still not complied with the standards set forth in the 90s, in the 96, this one, 1986 rule, act. So that is really shameful. That's something. So as a local body, what are the things which matter? The content is, I'm just going through the factors influencing the decision, the typical characteristics, and I'm just going through the treatment technologies. It's not elaborate in itself, but it is some of these technologies which are already established and proven in this country. And just a snapshot, you can look at it as a wastewater treatment technologies for dummies, or in 15 minutes. You could look at it like that. Then some strategies for septage and sludge management, some innovation, and one least known aspect of something about the use of biosolids. So the factors influencing the decision is the population and the project duration. So every urban local body should know what is their current population. But now the 21 census data should come out anytime, but we should be abreast of that. So once we know the population, we also need to know how long are we designing this project for. Typically, STPs can be designed for 15 years period. Sewer lines usually take a longer time. So we should be very clear about what we are doing, because if you look at the statistics of CPCB, we have 47% capacity for treatment, 37% capacity for treatment, but the actual utilization is only 27, which means there's a lot of mismatch between the treatment plant capacity and the actual sewage which is entering the plant. So this is an investment which is lost, because all electromechanical equipments are typically, the supplier will guarantee 1 year from the date of supply, from the date of commissioning, or 18 months from the date of supply, whichever is earlier. So this is how it goes. So by the time you really test your pumps, blowers, and motors, your warranty is over, and you're still waiting for the sewage to come in. We were part of a team which did this audit for the National Mission for Clean Ganga sometime back earlier, some 5-6 years ago. We found STPs waiting after commissioning for 3-4 years, good 3-4 years, with not a single drop of sewage coming in. So this is a problem with the planners. They should plan it in such a way that both these people will be commissioned at the same time. STPs are huge, expensive, but can be commissioned at a short duration. The sewer lines take a long time. So we should phase out the project in such a way that the STPs are planned, but they should dovetail in it so that the STPs do work. They can contribute at least 40-50% of treatment efficiency. Why wait for the last drop to be picked up? So that's the most important one. Then the characteristics. People should know what is the influent and the effluent characteristics. Now, this is very important, like Priyanka was talking. We should know the baseline of a city. Now, it's not a rocket science as such. Once we know the community which is catering to this, you don't need to do precise research on the wastewater characteristics, because the characteristics go up and down. But there are ranges which is given in the CPHO. As long as you can follow it, you can be rest assured that 95% of your wastewater treatment is done. We don't have to relook at the data. One, effluent characteristics is very important. That you should not lock up your money trying to achieve the let's say drinking water standards. It is when you are pushed to that, you will always find drinking water there. But right now we have to look at avoiding pollutions in a water stream and in the groundwater, the soil. Once this is done, if you already know these standards, 30 is the minimum now, so we can design your project. Site characteristics, slopes, terrain, head, drainage, all these things has to be looked into it before we can finalize a technology. Do not finalize a technology which then you will have to counter with pumps and motors. Type of reuse, like I told you. So you will have to see if there are agricultural land around you, it's good to treat it to a standard which the plants like. Now WHO as FAO has got a different standard for different type of crops. The crops which can be which are supposed to be eaten raw and which are root type of crop needs a quality A. B are the one which has some sort of processing where you salad crops which the product is on it does not touching the water, that's one, or you do some amount of processing, meaning cooking or something, so that's the type 3. And then the C type is one which is used for animal feed and other industrial use. So depending on the need for water, you need to treat it. So please understand, if you are using the water for growing fodder crops or something for industrial use, you don't need to treat it to a 30-10 BOD standard and take a lot of effort removing nitrogen and phosphorus, which the plants anyway need. So there's a lot of incongruity when you see that you remove nitrogen and phosphorus and then pass clean water to your field and then bring in NPK fertilizer and dump it there to grow the plant. It does not make sense. So when there's a natural nutrient present in water, use it. Only when you don't have it and you have to release it into a water body, please go to the extent of treating the water to the standards. So otherwise, so this is precisely what I was trying to say. Find the reuse, tailor your treatment technology to deliver that reuse consistently. That's one. So the ULB should also know what project cost they can lay hand to, the O&M cost they can budget for every year. And do you have product market? Meaning, if I am planning a USB which has a gas coming out as a product, fantastic, but then I should be able to generate electricity or bottle the biogas and supply. If I can't generate electricity and I don't find a customer for the biogas and then you're flaring it it does not make sense. So you have to understand what you're looking at. Then social and legal factors is something everybody knows. If you're putting up a complex technology, fine, but you should know whether you have the skilled labor for it. These were clearly visible during the last pandemic, where trained technicians went off to the hometown and a lot of STPs were stuck there without the proper people to run it. So these are something. And again, power, spare parts, etc. See, if you are dependent on some equipment and a part coming from China or Germany, and again, the pandemic is a good lesson for all this. Try to use technologies which have local vendors and stocks available. So these are the few factors which influence the decision. Once the decision is taken, you need to predict what flow are you looking at. So this is something a lot of people don't do. It is left to the consultants but as a city, one needs to know what water are we supplying. You can treat it to 150 LPCD, but if you're not supplying 150 LPCD, you're again doubling your investment. So know how much water you have access to, then consider that, multiply by your population, which is standard methods are given in CPHO. You can use the standard method, and once you define your project period, you can project your population, get the flow, and that is what is your STP capacity. Don't invest on something. I have seen projects where they've invested on few MLD plant and 15 years they have not received 10% of that water flow. This should not happen. So you should plan. That is what the English saying goes, cut your waste according to the cloth. So know what you have and precisely do exactly that. So the characteristics are given in CPHO. There's a range. Well, that is, you can do some dipstick measurement, but generally you can take this range. It should work. It will work. So the technologies which are primarily catering to, and this is also in the reckoner which Dr. Chaurase was talking about, you need a primary treatment, which is a bar screen, which is to prevent bulk particles like twigs and solids from entering in. So you have various sizes of bar screens. Then you have inert sand, silt, and those heavy particles. So you need a grit removal system. The partial flume is necessary for measurement. Many of the technologies do not have measurement devices, which means when it fails, nobody knows why it failed. Whether it's a problem with the pollution load or is it excess flow. So partial flume is necessary because you're working at an urban local body. Then the technologies which are of choice, I've listed here: waste stabilization pond, one of the cheapest and the oldest and very stable technology; aerated lagoon; root zone technology; activated sludge; extended aeration, and all those things. Now the technologies on the top require a larger land. For ULBs which have less access to funds can invest on it, which means the land is there, they block the land. So 15 years from now, when the plant size is becoming deficient or you are getting into a constraint, you can then think of moving into a sophisticated technology, because that time the technology would be cheaper. It will have a lesser footprint. You can cater to a larger load. So you are blocking the land. People are already aware. You won't have public protest or opposition to any technology, because kindly block the land. Land is the only thing which an urban local body has. So block it up, fence it up, declare your buffer zone, see that nothing comes on the vicinity of the plant. This is the most important thing, because everywhere the objection starts from the development which occur across the fence or the compound wall. So kindly block your land, reserve it. In 15 years time, that land itself is your asset. It will take care of a lot of your many problems. You can have better and better technologies, and then you can monetize that land also. And all the thing, once the water is treated, you need to disinfect. There are many disinfection choices. Chlorine disinfection is one of the cheapest and can be handled easily. So this is the nutshell of all the technologies. Now I'll just quickly skip through all the technologies which are listed. This eventually will come in the ready reckoner. So the screening, as you see, that's the bar screen. You can either do it manually or you can use an automated system. So both are available. These are very commonplace technologies and available across the country. Then you have the grid chamber, which is a module which is designed to filter out the heavy particles. It purely works on gravity. Again, the grid can be removed mechanically or once in a few months. So this both are possible. Depends on the size of the ULB. You can invest on one of this, but these two are mandatory, because without this, the rest of the technologies will land up into trouble. Partial flume, I told you, this is for measuring the flow. It's nothing. It's just a sensor kept on top of a small drain, which will measure the flow. This is very important for the understanding whether the plant is receiving the flow which you have designed, or it is in excess or is under. So now this is the actual core technology, secondary treatment, which actually treats the water and reduces the pollution. Aerated lagoon, which is like a large pond, which has some few aerators kept in it. So the type of land requirement is 0.27 to 0.4 hectares per MLD. So depending on what time span window you are projecting, you can block out your land, and that's the area which you need for sort of forever. You can look at it like that. Yeah, and the energy requirement, all the data are here. Is one of the cheapest, simplest to handle type of technology, aerated lagoon. Then you have the activated sludge process. It is one Brahmastra type of technology which everybody uses. Very proven, very old, and very successful. So again, the area you can look at it. Area, why I'm stressing, because that's the one place where urban local bodies land up in trouble. We have worked in Kerala, and everywhere the ULBs have, once the ULB limits end, the next ULB urban expansion starts. So you have to block out your land in the thing, and where you have 2 or 3 ULBs together, one might also look at cluster type of approach. That's also possible. So this is the ASP where the wastewater enters, you just bubble air through it, and oxygen goes, the bacteria which are there treat the pollution. So all this technology which I am showing now are ideally meant for sewage. Sewage is the one which is more liquid, less solid, which flows through a pipe, sewer line. So this end of the pipe, you have a sewage treatment plant. Now, when we say sewage treatment plant, it does not matter whether it is one end of the pipe system for an urban local body. It could be for small ASPs for 100 KLD, 200 KLD, 500 KLD for a small ward also is possible. It all depends on how the urban local body wants to plan. You got a very high degree of efficiency. You can expand as necessary also. You can add additional modules to increase the treatment efficiency. Yeah, but it requires skilled operators. But once you have a skilled operator, you train them up, and if they're there, there's no issue with these technologies. That way, comparatively less complicated. SPR, one state-of-the-art technology, very good, requires far more skilled operation and a lot of electromechanical equipments in it. Good technology, well proven, can be utilized by an urban local body. It will cost a little more. That's one thing. Its footprint is less. Then you have the tricking filter. Again, very proven technologies. It has got high construction cost. The thing is, it's a little sensitive to temperatures, so you can go it for moderate and higher temperature area, not for the hilly terrains. That's something which you have to keep in mind. MBPR is again a state-of-art technology which a lot of people are using it, right from small capacities to large ones. The areas, the footprint is low, you get very high quality water. Yeah, the whole efficiency depends on the media, which is the plastic media, so it depends on the supplier. Then you have a combination. See, all the technology which you've seen till now works on aerobic, which means the bacteria needs oxygen for its survival. But what I'm going to talk now is a class of technology which works on anaerobic bacteria, which do not require atmospheric air for its functioning. So UASB, upflow anaerobic sludge blanket reactor, and combination of it. So what we do, we have anaerobic technologies, couple it with aerobic technologies to achieve the required results. So you have here the UASBs with the polishing pond. So polishing pond is nothing but what I told you in the beginning, a similar pond attached to the effluent of the UASB. So that's what is done. Then you can also take the discharge from UASB, apply it on land. This is ideally suited when you have agricultural land next to it. This might have a smell, but it's still okay if you have large tracts of fodder and forest area. Then you have tricking filter. You get very good quality water. It will reduce the cost of treatment. Then you have ASP, again a proven technology. The front-end technology, which is doing the main treatment, is UASB, and the polishing is done with an ASP. So now with this combination, you can also have decentralized treatment system. This is like Binisha was talking, should not be considered as a mainstay solution for this for an urban local body, especially a larger one, because more you make it decentralized, you need more monitoring, and it becomes more complicated it's really difficult to prove whether everything is working. But there are situations where this is the only solution, especially where your trunk lines and the sewer lines are not, it is not feasible for you to connect your isolated loads. Certain wards are low lying, you can't connect it unless you have a lift well and a pumping system, in which case these things do work very nicely. And especially when you have gradients, this is one of the best systems to be used. The beauty of the system is you don't need chemicals and electricity, nor do you need regular attendance. As long as you periodically monitor it, this is good. So Priyanka actually mentioned this in the decentralized system, the one which was in the Saulkare Lake, which we have executed, and ATREE themselves have one plant in their campus, which has been working since 15 years. This system can actually deliver the standards, whatever you want. You can also scale it down to a standard which is amenable for your reuse. You can then expand it in conformance to the law. So then comes this septage. Now septage, I think Paramita is going to draw the distinction, but just a quick this thing. Septage is more slurry-like, is more solids in it, and this is typically an outcome of a septic tank, an on-site sewage. Then there's another thing called fecal sludge, which is from all other treatment technologies, which are on-site treatment technologies, which is even more having a bit more solid. So very fine line within this definition of septage and fecal sludge, but Technically, these are thick. They don't flow through sewer lines. That's the most important part. Now it comprises the water part and the solids. So the way we work is we separate out the solids and the liquids somehow meaning I'll get into that in the next slides. So you separate the liquids and the solids. Solids you handle separately, the liquid you handle with one of the earlier technologies. So what we do is we suck out this the sludge, the septage or the sludge through using a vacuum truck. No manual labor to be used. It is a direct contravention of the Prevention of Manual Scavenging Act. So that's you use a mechanical equipment to pump out the septage or the sludge and then take it to the treatment plant where this separation is done. So you can either move it by an automobile or you can take it and inject it into the sewer line laid nearest manhole, which the regular sewage will then take this septage, this thick slurry, and eventually take it to STPs. So these two are possible, but one has to check whether the STPs designed and implemented in the local body is capable of taking the load. Typically, it would. The good thing with this is then it reduces the potential for human contact with fecal-borne pathogen. It's highly loaded with pathogen, and something like 7 lakh CFUs per 100 ml. Then it also reduces the odor. And what she was talking about, contamination, groundwater, all this can be handled if you have a properly designed septage and fecal sludge management plant. So the various technologies which are available in India, you have the non-biological, which is straight away dewatering and burning. That's the type of technology. There are other one of the natural system. You have the decentralized system, sludge drying bed, upflow, USB, sludge settling, all those things. These are all a combination of the technologies which I told earlier. Somehow you have to sieve out the water and the solids, and then you handle it accordingly. So basically what you have is a drying bed, something similar to the strain system which you have. You apply the water, the sludge and the septage and the sludge on top of it. The water will percolate through and the water is collected and handled in one of the other technologies. The sludge will dry there, and then after a certain period of maturation, it can be used as a compost material, or it could be co-composted in a solid waste management plant. Now I'm bringing in a new innovation which was adopted in Nasik. Like what Dr. Ajit was speaking, solid waste entering into water bodies, and because finally, as far as environment is concerned, it's pollution, whether it is from fecal sludge directly or solid waste independently dumped into water body, it's still the same. So every urban local body is vested with this challenge of managing the biodegradable waste, food waste and vegetable waste. And also, if they are not sewered, you also have a problem of the septage and the sludge. Now, instead of putting two different systems to handle solid waste separately and the fecal sludge or the septage separately, or a sewage treatment plant, why not combine these two into one if there is potential benefit? So this particular project was installed in Nasik under support from GIZ and the government of Germany, where 20 tons of solid waste and almost 10 tons of sludge, fecal sludge from the community toilets and the public toilets from Nasik were introduced on a daily basis to generate 250 kilowatts of power. So that's the thing, and it's a small footprint, 1.5 acres of land, just 6-7 people handling the show, and 20 tons. With 20 tons, if to put it in perspective, is a small town of 25,000 population. A small town of 25,000 population with septic tanks, desludge once in 2 years would ideally be a client for this project because everything is closed looped here. So basically you put the food waste and the sludge into one, digest it, generate the methane, burn it in a combined heat and power plant, generate electricity and send it into the grid. The water itself is reused and or can also be used for irrigation. The solids which come out can be converted to fertilizer and again compost. So virtually it's a zero loop and a one which benefits the climate because the methane is burnt usefully. You are avoiding the use of fossil fuel. The interesting part is in comparison to a standard solid waste, a biodegradable compost plant or any other technology, for degradable waste and an STP separately, this project is viable for all the three stakeholders. All the three stakeholders meaning the urban local body, the operator who is funding and operating this project, and the city. So you can see there, every one of them, the first, the left side shows that over a conventional business as usual case, the urban local body saves almost 1/3 of its money. The operator gets almost 20% additional profit, and that is about 30% additional profit for the operator. The city as such stands to gain because you have one project which does everything, small footprint, less number of people, no emissions. Reason is the emission is the one which is getting burnt and converted to electricity. No operator, no ULP would like to lose anything by way of stink, because that's what we are burning and getting energy out. So that's the one of the models which small ULBs can do, and you can have multiple such projects. So this is one thing which I wanted people to deliberate and dwell on this. Now, once you do all this, you get a sludge, and this sludge can be, after thickening, radiation, dewatering, can be used as a fertilizer. Now, this fertilizer, or some countries do actually dump it. It's a waste of valuable nutrient. In India, the soils are carbon deficient. So even if you put as much NPK you want in commercial fertilizer, the soil will not deliver its results. So you need to have matching amount of carbon. The farmers as of today use farmyard manure, dung from animals, to substitute this. And now with rapid urbanization, even this is not available. So using the manure which comes from this from such a plant can help there. But now what is required is, the USAPA says that your fecal coliform density should be less than 1000 mpm per gram in the solids, and salmonella should be less than 3 mpm. So these two are important, and also the Helminthal concentration of less than 1 number per gram. So as long as we can ensure that the sludge, instead of just drying, see, many FSTPs do the mistake of drying it and getting it into and claiming it as an agricultural fertilizer. It is not, unless it suits this and conforms to this criteria. This should not be encouraged with the current level. One has to go ahead and take sufficient precautions to ensure that these biological pathogens are eliminated or reduced. Yeah, that's the key message I want to say with urban local bodies, because many such local bodies are taking the so-called panacea as fecal sludge treatment plant, put one plant and hope that everything goes right. It does not. You have to take care that you have a ready scheduled desludging should be there, otherwise it should be part and parcel of that. Otherwise, not when a fellow complains that the septic tank is overflowing, you pick up water. Unless you want environmental pollution to be controlled, you need to ensure that everybody, like a clockwork, you pick up house number 1, 2, 3, 4, 365, come back again. So it should be like that. That system should be there, which will ensure the viability of the FSTPs. That's one. And the product which come off it should conform to the biological contamination parameters. If these are closed looped, and then you also plan in such a way that the sewer lines eventually come to the city, because that is what is necessary. And this FSTP should be part and parcel of the FSTP. Of the sewage treatment plant. So so my message for urban local body is, estimate your population and your project duration, find out the largest area required by one of these 15 technologies, block that land, declare buffer, master plan rules, development zones, and all those things, block it up. Then you can go for a FSTP which will fit into the larger game, and then start with that. Continue your sewer line system. Start from the plant, go upwards, build a smaller plant, upgrade it modularly so that your plant and the sewer line are proportionate. Don't block your funds in doing something like a 30-year plan and building an STP which will get scrapped before your sewer lines come. That's my message. Any questions you can ask me.
I just request everyone to put their questions into the chat in the interest of time. So thank you so much, Mr. Pravanjeet, for giving us an overview of the conventional systems and how much they cost and what it entails to install it, and also innovative ideas of how one can do solid waste management in conjunction with sewage management. I would like to introduce the next speaker, Ms. Paramita Datta De, who's the head of resources and waste at NIUA. Parimita De is a city planner and has almost 20 years of experience in urban development, water, and sanitation. She also has worked with urban poverty reduction and policy and program development, program management, environmental and social assessment, and monitoring and evaluation. She's worked with various ministries in the government of India and has on internationally funded projects, and has been engaged in a number of policy initiatives in the urban development sector. Over to you, Ms. D.
Thank you, and thanks to all the organizers and the hosting team for having me here, and specifically to Mr. Pravinjeet. So I'll quickly begin with a little bit of number crunching. According to the latest report by the Central Pollution Control Board, which was released in March 2021, the sewage generation that out of the 72,368 MLD of sewage that is generated, only 20,235 MLD is treated. That is as per the CPCB report released in March 2021. And among this, which my earlier speaker have spoken, that is only the 5 states of Karnataka, Maharashtra, Gujarat, UP, and NCT of Delhi, they jointly contribute to 60.5% of the total installed capacity, treatment capacity in the country. So all my earlier speakers have spoken about this fact that a lot of sewage that is generated is not treated. So I'll just quickly tell you what this report by the CPCB recommends. First of all, we need to bridge the gap. Secondly, the existing infrastructure is only 75% of the operationalized treatment capacity. Therefore, the sewage conveyance treatment that includes the laying of sewer lines, sewer connection to individual household, that has to be greatly strengthened. As Mr. Pravinji just mentioned, that a lot of times the STP is there, but the connections are not laid. So there has to be coherence in this. And out of the STPs that are treating wastewater currently, only 23% of the treatment capacity is able to meet the parameters. So Mr. Pravinji also mentioned that without actually faulting in meeting the parameters, how you can use the wastewater generated in a more judicious manner in agriculture and other such purposes. But however, the operation and maintenance of treatment plants are extremely imperative. The report encourages ULBs to focus on utilization of treated sewage for non-potable purposes, which we heard the earlier speakers talk about. It includes horticulture, irrigation, firefighting, industrial cooling, toilet flushing, washing of roads, buses, trains, and so many other uses. And it also, there is a lot of encouragement about industrial clusters and zones that can use treated water as part of the requirements. And treated sewage can be used, and this has not really assumed so as much importance as it should in policy and planning in many states. And just to give you a little bit idea of what's happening all over the country, the proportion of reuse of treated sewage is maximum in Haryana, which is 80%, followed by Puducherry 55%, Delhi 50%, Chandigarh 35%, Tamil Nadu 25%, MP 20%, and Andhra only 5%. And the Delhi government has set a very ambitious target to reuse to 60% from 12.5%, which is the current. And reuse of treated sewage can decrease the water demand. So that needs to be emphasized, especially when we are using water from aquatic sources like rivers, ponds, lakes, and also groundwater. So less consumption of raw water will help in conserving our natural water resources also. Now coming to fecal sludge. the data says that a vast majority, about 38% of our houses have toilets connected to septic tanks. And the construction of these tanks is sometimes not proper. A lot of times they're buried underground in densely populated areas. As a result, the treatment of sewage is partial. Now, that's where these kind of decentralized approaches may help. And while every city aspires for 100% connection to a sewage system, creating this infrastructure, particularly in smaller cities, can be very resource intensive, and also it is the cost is very, very prohibitive. So we should look at alternate solutions in a decentralized manner. Management of excreta on site by using septic tanks in pit latrines is therefore a necessity. Now, if you look at the census figures, around 45% of urban houses in India depend on on-site systems. And a large part of the wastewater from these systems seep into the soil, and this may penetrate enough to pollute groundwater. So therefore, emptied fecal sludge should ideally be sent to a treatment facility where it should be treated to meet the standards set by the Pollution Control Board. However, this does not happen. And if you look at the census data, that 65% of the cities in the country do not have proper arrangement for safe collection of human excreta. So safe sanitation as envisaged on the Swachh Bharat mission entails safe management of human waste generated in the urban toilets in the country, and that they rely mostly on on-site sanitation systems. So in order to ensure that the intended public health and environmental benefits of safely managed sanitation is achieved, the fecal sludge and septage management provides approach. This provides a low-cost, easily scalable, and inclusive sanitation solution, and it can complement India's ongoing efforts to extend sewer networks by prioritizing on the safe management of human waste in a time-bound manner. And in this context, that is where I would like to say that the National Fecal Sludge and Septage Management Policy was launched in 2017. And since then, a lot of work has happened in the country. A number of good practices have emerged in various states of India. Particularly, I would like to highlight Maharashtra, Telangana, Odisha, and Tamil Nadu. And these states are fast moving towards scaling up of innovative and inclusive urban sanitation delivery. In Odisha, in fact, has also established an academy for this purpose to train people coming from smaller ULBs. All this demonstrates that a collaborative approach where the private sector, civil society have joined hands under the leadership of the state and the local government. And this kind of human-centric design and gender aspect across the value chain have been the ingredients of success in these states. I also would like to highlight that Niti Aayog has come up with a document called Fecal Sludge and Septage Management in Urban Areas, Service and Business Models. So this document is very well synthesized the learnings across the leading practices in the states that I just mentioned. Additionally, at NIUA, we have also come up with several knowledge products that have emerged from these experiences, and they are available at our website. Now, we might wonder what is the need in terms of investment. So this report also gives a quick figure. It says that in India, an investment of 12,000 crores is required for fecal sludge and septage management. And this is a key pathway to meet the Sustainable Development Goal 6.2 of safely managed sanitation by 2030. So we are all aware that SBM has been a Jan Andolan, and the country has made significant strides in terms of sanitation and fecal sludge management. And there has been a evaluation by the Niti Aayog on Swachh Bharat Mission Urban, which came out in January 2021, and it made a lot of recommendations, but I'd like to focus the ones on septage management and sewage. So it says that there has to be continued investment in individual household toilets, community toilets, and public toilets. And there's a great need to focus on the entire value chain for inclusive sanitation, which includes collection, containment, treatment, disposal, and recycling of fecal waste, as well as wastewater. So it is in this context that Swachh Bharat Urban 2.0 was launched, keeping all these recommendations of Niti Aayog in mind, and the total outlay is far more than Swachh Bharat 1.0. So the outlay of SBM 2.0 is 1,41,600 crores of rupees. And SBM 2.0, as you all may be aware, that it says that all cities have to become garbage free, and it ensures and they have to ensure that gray and black water, that is now being called used water, is managed in all the cities other than those covered in the Amrut mission. Now, they have also come up with ODF plus protocols, ODF plus plus protocols. So till 2nd October 2021, about 3,309 cities were ODF plus, 960 cities were ODF plus plus, and 9 cities only were water plus. And this was verified through a third-party verification. Now, SBM 2.0 has a lot of focus to sustain the ODF status and to ensure that no slippage occurs. So MOA has introduced the ODF plus and plus plus protocol. So ODF plus basically means the focus has to be on the operation and maintenance of the community toilets and the public toilets by ensuring their functionality and proper maintenance and continued with that comes with continuous usage. And ODF plus plus protocol basically means that one has to focus on addressing the safe containment, evacuation, transportation, and processing of fecal sludge from toilets, and also ensuring that no treated sludge is discharged into open drains, water bodies, or open fields. And water plus protocol is again something that SBM 2.0 is focusing on, which says that no untreated wastewater should be discharged into the open environment or water bodies without reaching the prescribed standards. And it says it has a very, very ambitious vision. It says that all urban local bodies should become ODF plus, and those with a population of less than 1 lakh should become ODF plus plus and water plus by 2026. That is the target year for SBM 2.0. And it has also ensured that all cities should come up with city sanitation action plans. Now, state sanitation strategy and city sanitation plans was something that was focused as part of the national urban sanitation policy. So SBM 2.0 is kind of trying to bring that back. In between, it was not talked about so much, and cities were not actually updating their plans and policies. So now SBM 2.0 is saying that they will fund desludging equipment for scheduled and need-based desludging of all septic. Going to fund interception and diversion of drains, including last mile connectivity, and it is also going to fund construction of STPs and STP cum fecal sludge treatment plants. This was not there earlier in SBM 1.0. So SBM 2.0 is ambitious. At the same time, it's very inclusive, and it talks about long-term sustainability. So with that, I would like to sum up by saying that if we want to get into long-term sustainability and quality implementation, states and cities must undertake a holistic approach in terms of capacity building, quality assurance, quality control, and last but not the least, monitoring. And all these efforts have to be made keeping in mind the most vulnerable, the underserved, women, and urban poor at the center. So I think it's time that India can now lead by example by not only ending desertification but also safely manage sanitation. Thank you.
I think you can go ahead.
Oh, I finished with what?
Okay,
Could you not
sorry.
hear me? I was wondering.
No, I think
Be short because everybody must be.
no. I appreciate that. Thanks for giving us a overview of the Swachh Bharat 2.0 mission, and also emphasizing the importance of a holistic approach, also keeping in mind that wastewater reuse is imperative when creating a strategy for how the treatment is also done. I would like to move on to our next speaker, Dr. Manish Chaudhary, who's a Scientist D from the Technology Development Board. He's an experienced telecom professional with 24 years of extensive experience in different, in a spectrum of things, including technology, product development, system integration. And he's currently working in the capacity of a Scientist D at the Technology Development Board and is engaged in scouting and project financing of proposals received from startups and small and medium-sized enterprises, particularly in the domain of electronics, cybersecurity, IT, and telecom. Over to you, Dr. Manish.
Thank you, ma'am. Thank you for the introduction. And I'm really, I am from a different domain. Basically, I'm from telecom domain, but I am really awakened and enlightened by the wonderful talks on the waste management by the keynote speakers. So I'm thankful to all of you, and thanks for this opportunity for presenting a technology development board. I would like to share my presentation, a small presentation on TDB's funding guidelines and how to avail the funding from TDB. So I'm just presenting my desktop. Just kindly acknowledge if it is visible to you. So is my desktop visible to all the
Manish. Yeah, you can go ahead.
Yeah, thank you. I'm here representing a technology development board. A technology development board is basically a statutory body under Department of Science and Technology. Before I go into the agenda of the presentation, I just wanted to mention here that TDB has been at the forefront for funding various technology on the waste management. And TDB recently floated a call for proposal on the waste management, and TDB has received a good response with respect to its call for proposal on the waste management through indigenous technologies. We have received, as on date, 51 application proposals on addressing a different aspect of the waste management. Like most of the proposals we have received in our call for proposal is in municipal and waste management, agriculture waste, and industrial and the plastic waste. So all these proposals are in addressing a different paradigm of the management of the waste through technology interventions. So this is what TDB has been doing, and recent initiative of the TDB with regard to the waste management. And in the past, also TDB has supported various companies who are working aggressively on the waste management issues. Like in the past, TDB has supported the Anaerobic Energy Private Limited for developing and refining the biogas to produce the bio-CNG from sewage. And other such company is also the Can Biosis India Private Limited for commercialization of the rice straw utilization technology for addressing a stubble burning issue. So there are some basic companies which TDP has funded in the waste management domain. So there I would like to present some success stories of TDB. Like TDB is the first one who have funded the automotive sector in the electric vehicle space. Like River Car was funded by the TDB when it was in a very nascent stage, when the electric mobility was in a very nascent stage. TDB has been instrumental in making India the pharmacy of the world. TDB has funded number of companies in the pharma sector, like which are now big giant like Bharat Biotech, MyLab, Ranbaxy, Cadila. All these companies are in one or other form in stage are being funded by the TDB. And TDB basically support a sector agnostic from IT to defense to waste management. Any of the company can seek a support from TDB. So basic agenda for my presentation today is like I would like to present the mission objective of TDB, a silent feature of TDB funding criteria, TDB at a glance, and TDB evaluation process. So these are the basic things which I would like to go about it. So technology development board, as I have told you earlier, that it is a statutory body of DST enacted by the Act of Parliament in 1995, and it has been around 25 years since TDB has been uh, enacted as per the Parliament Act. So the main vision and mission of the TDB is to help the technology weakest zone help the zone of technology development and commercialization, even at the risk of failure. TDB comes into picture when the technology is ready for the commercialization, when the prototype is ready, certified, and the entrepreneur is looking towards commercialization of the technology. And at that point of time, TDB funding comes into picture. So basic objective of the TDP is that to foster the innovation in the frontier market technologies in deep tech areas and help in the commercialization of the product. To help in the import substitute, adaptation of the imported technology for the water domestic use, and to enable the Indian industry to become a global player, and to also assist in the core strategic sector, which and make them profitable and technology intensive. So the salient feature of the TDB funding is that interest rate is 5% at simple interest, and after the completion of a project, there is a 1 year moratorium period. So it is at a very simple framework of the funding, and repayment time frame is basically a 4.5 years with 0.5% royalty on the annual sales turnover. TDB project during the course of evaluation is assessed by the various technology industry experts. So they provide a lot of handholding to the project during a time of execution. And TDB scheme is sector agnostic, as I have told, and it is open throughout the year. So any applicant is interested in availing a TDB funding, they can apply through our website at any point of the time in a year, and it is sector agnostic. So project cost which can be funded with the help of TDB assistance is that TDB can fund the land, site development, building and civil works. That includes the factory administrative cost, plant and machinery. It can be imported or indigenous. As fixed assets can be supported by TDB. So all the capex items, all the capital items which goes into the commercialization of a project can be funded by the TDB. TDB also fund the margin money of the working capital, but TDB doesn't support the working capital as such, but margin money can be supported by TDB. Apart from that, TDB supports in filing of patents and licensing of technology from the foreign sources or any other R&D institute. But point here is that TDB support is limited to the 50% of the project cost to be incurred. And TDB support is available to any registered startup with a DPIIT, MSMEs, and any industrial concern, but all have to be under the registered under the Companies Act as per ROC. So this is the basic criteria of availing a funding from Technology Development Board. So the project submitted at the TDB have to go through a two-stage of evaluation. When the project is submitted to TDB, first there will be a initial screening committee will be planned, and that initial screening will see if the project meets the TDB's funding guidelines and it meets the TDB's criteria of funding. And if the initial screening committee recommends the proposal, then it is evaluated by the second level of committee, which is a more detailed evaluation, and it is done generally on site. And if the project cost is more than 10 crores, then there is third party due diligence also. And so if the project is recommended by the project evaluation committee or by third party as well, the project is submitted to the board for approval. And after that, the loan is sanctioned to the company. TDB funding assistance is available in the form of loan, equity, and grant. But currently, most of the funding goes from TDB in terms of loan. So this is just about a TDB at a glance. Like TDB, since its inception, has uh, given a major funding in terms of the loan, but other form of loan funding available from the TDB is in form of equity and a grant. TDB has also participated by venture capital to reach out to the more startups and industrial concern through the venture fund. There are the other sources through which TDB has funded and benefited the companies through the other programs like Invent program. TDB has funded around around 140 social enterprises to avail a second level of funding. TDB, along with this program of Millennium Alliance, has disbursed on 24 crores for total for technology, social startups, and Millennium. And TDB has also funded through the Gita Enterprises by foreign collaborations, and through VCF funding. TDB has tried to reach out to the more companies and startups. TDB, as on date, has signed 373 agreements with companies, and with that, TDB has created a value of around 88 crores, where the TDB commitment is around 28 crores. TDB has funded most of the companies spanning all over the India. This is basically the agreement sector-wise showcased here. And TDB, any applicant can apply to TDB through its website, and funding guidelines and other details are available on our website. And we can be also reached through a different uh, social media platform as well. So this is what I wanted to share a little brief about the Technology Development Board and how to avail the funding from TDB. So I'm open for any questions if there are.
Perhaps there might be some questions in the chat which we can share with you later. With that, I would like to introduce our final speaker for the day, Dr. N.B. Mazumdar, who is the chairman of the International Academy. Dr. Mazumdar, perhaps if you mute yourself once, I mute myself.
Okay.
Okay, I'll be brief. Dr. N.B. Mazumdar, who's the chairman of the International Academy of Environmental Sanitation and Public Health. As an international waste management expert, he's been involved with waste management and on-site sanitation for 3.5 decades in different parts of the world, working with various international organizations. I would request you to go ahead and make the closing remarks for today's talk.
Okay. How long do I get? Because we have crossed the time. Sorry for the glitch. Well, it was a great pleasure for me. Thanks particularly to Pravinjit and Ms. Benisha that I got this opportunity of at least learning something from here. You see, it's always a pleasure to have professional interaction. Ms. Benisha, if I just quickly go through what I absorbed, So first, Ms. Benisha set the tone and she showed us very good slides, some photographs and all, followed by Mr. Chaurasia, who I would say that he said a very important, because it came from a government officer. Let's make a beginning. Okay, so that I think is a great sentence. And he has been dwelling with all this for a long time. But his enthusiasm is very important for all of us in the sector. And for the from the TDB also, because finally the sovereign is their reaction and their involvement and their enthusiasm is of utmost importance for all of us, all the professionals. So I was really happy to hear Mr. Chaurasia. Then Mr. Jain welcomed us all. Mr. Ajit from Kila, he told about the, first of all, I just, he reminded me of my long back brief associations with Kila, say in the years 1998, 99 or so, when Kila was just done. So I used to go there for giving some lectures or having some interactions and so on. So it was long back. But anyway, he gave a very good, description about what Kerala is doing. And what he, one very important thing he brought out was about the community-owned projects. That I think is very important. The community-owned and community-managed. That is very important, and particularly with relation to the rural areas, because we cannot, the government, whatever the central government or the state government or even the urban local government, they cannot go into the rural areas. So the panchayats and the rural people themselves, the community has to really get into this. Then only things would be sustainable. Followed by that, Dr. Priyanka Jamwal, she mentioned a lot of research. Some of it was very interesting, and I hope that these useful experiments with Sludge and Blackwater would be actually, would see the light of the day from the point of upscaling and actual use in the field. And then, of course, Pravinjit gave us a very detailed description. I think it was like a class. I mean, like like a professor. He taught us about the STP and particularly about the STP, how to design, what to design, when to design, and how much to design. I mean, to phase it out and do a modular way. This, I think, Pravinjit, is very, very important because I have seen here, I have worked with some STPs here, and I've found that many of them, as you mentioned, are not really working properly. I mean, what about, not to say about the extent of working or the underutilization that is completely rampant, but some of them are just not working. So it's a huge misuse, or I would say loss of public investment. So I think Pravinjit's point was very important, that they should first of all properly plan and then plan in a modular way. That is very important. I remember again that during 1998-99, when I was in HUDCO, we were given 5 STPs to evaluate by the MNRE those days as to how best to use them for energy generation. And as he mentioned, we found that in many, either the sewage which was coming during the rainy season, it was so dilute that the volumetric efficiency, it was not there. Or on the other hand, there was very little sewage. So either it was completely underutilized or the sewage treatment plant was just overwhelmed. So neither of them was working. So we need to be very, very cautious in planning. And I've seen plants here also where a lot of, because they get a lot of space. Now the space is also not properly utilized. Say public space in a city, particularly in large cities, mega cities like Delhi, Mumbai, and others also, Hyderabad, Chennai, all the places. It's a very expensive thing. And so much of land is there which is not properly utilized. So whenever possible, they should properly plan in a way that the land use should be optimal. And whatever extra land is there for future use, that land can be planned for use temporarily. They can go for, medicinal plants. I mean, they can plant medicinal plants or any other thing, which should be properly, the land should be properly utilized. Now, coming to my part, because I won't take much time, I would quickly put my points about, while my closing thing. See, about the sewage thing, we have heard a lot of issues. Drainage has not been much discussed, a little bit, of course, but I do feel that the drainage is also extremely important. And if we look at, just open your TV or your newspaper these days, it's all filled with visuals of flooded areas, whether it is a town or a village. Now, a flood in a river is a completely different thing, but a city which is flooded without any reason, that can be definitely addressed. And it's not a one-day thing. We do have master plans, like Delhi had a master plan which was done in the year, I think, 1985. Another master plan was being made. But in the meanwhile, whatever development happens, the drainage doesn't, keep pace with that. In the year 2007, I remember I had an opportunity of working for the city development plan for Delhi. And I was responsible for preparing the surface drainage and the solid waste management for Delhi. When I got into the surface drainage, I found that in those days, and of course now MCD is again united, so there were 6 numbers of authorities. All the ULBs, then the irrigation and drainage. So all told, there were 6 drainage authorities. And come rain, and they start fighting. Every year this happens. I mean, in Delhi, it's a very common phenomenon. And when I got into this, I found that Delhi has 5 drainage basins, natural drainage basins. Every city has. So I'm just giving you the example of Delhi. Now, if the drainage is done, in Delhi, we had 1,296 man-made drains in those days, and there were 32 natural drains. So ultimately, what I suggested in that was that all these natural drains should have in situ treatment system. I took help from the IIT Delhi, and we worked out the cost and everything. The cost was not very much, but somehow that didn't happen at that time. And fortunately or unfortunately, the drainage problem was converted into a transport solution. That is what happened. All the drains were covered, some flyovers were made over them, but the poor drainage system has remained poor. So I would like to emphasize that drainage must be taken very seriously, not only in Delhi, but all the cities, whether small or large, so that at least in this 21st century, we don't have flooded cities during the rainy season. We should have in control. Now, about the other things, one thing we have not discussed, which we would like to mention, is COVID surveillance. You see, we had done other surveillance systems also like polio, but with the onset of COVID, we had seen that it could be possible to have a COVID surveillance system by which you get a time period of 3 to 4 days, during which the micro containment at least can be managed in a far better manner. So this can be done. I mean, we had actually from my institute, we had made certain plans and we were trying to get certain funds, but somehow it was not available. We got the NDMC also interested, but funds were not available. But I do very strongly feel that every city should have the COVID surveillance system with their sewage system, as well as, if it is not there, whatever system is there for disposal, it should be tagged with the COVID surveillance system. Now, for the other things, generally, I'm repeating to some extent what Pravinjit said. We need holistic planning. I think Dr. Paramita also mentioned, she told us about a lot of data. So it also shows that holistic planning is extremely important, whether you need a centralized facility or a decentralized. And in my opinion, for efficiency, it would be a combination of centralized and decentralized. Then only it can work, particularly for larger cities. But each city, each village is an independent entity. And that is why a project report is prepared. That is why a feasibility report is prepared. And that is why finally a detailed project report is prepared. The detailed project report should have everything. It should have everything in it, from the requirement of the buffer zone to each and every part of the treatment system, the collection system, how much of decentralized, how much of centralization, who is going to manage. And I would like to emphasize another thing, because we have a very august gathering. We must convert into the habit of taking into account life cycle cost. See, I have been into finance when I was in HUTCO for more than 11 years. I'd been into finance, both debt financing as well as equity financing. But what we got as project was the NPVs and all, the net present values and all those things. but they don't give you a complete picture. And in these more than 4 decades, I've come to the conclusion that if you take the projects, the cost, the life cycle cost, then most of the problems of the project would be solved and decision making would be much better. You see, the cost which has been done with the commissioning date in view is not the real cost, because if your concession period is 15 to 30 years, you have to do something about that also. So that is where the life cycle cost comes in. And if you take the life cycle cost, then the chances of failure of a project, whether black water or gray water, would be minimal. See, look at our systems. As we have, I've also learned so much of data now. The percentage of actually working plants, what is the percentage? So that shows. So therefore, the life cycle cost is a very important thing. Another important thing is, there was a lot of debate and discussion about the value, the BOD 10. See, we are, those who are actually on the field, for us, it's a big thing whether the BOD value, the limit is 30 or 10. It's a big thing. But in my opinion, my personal opinion, we should also go for the absolute value. And our authorities must look into it. If I have 30 BOD and my discharge is, let us say, in certain kiloliters, how does it matter? But if my discharge is in MLD, or let's say 100 MLD, 200, 500 MLD, then the difference between 30 and 10 is going to be huge. So can we evolve a system? Can we work out a system by which the absolute value can also be taken into account, not just the 30 or 10? If I have a very small discharge, how does it matter? You see, for the environment, it's a very minuscule, addition or deletion. Then another important point which was discussed was capacity building. What I find is there is a huge lack of capacity building and planning capability in our, amongst the people who sit on the other side of the table. See, I have had the chance of sitting on all the sides of the table. I have worked with the state government, central government, NGOs, private companies, and all. So I must say that there is a lot of requirement for capacity building and planning capability for those who sit on the other side of the table also. Because you see, most of the government funding is tender driven, right? Take up any tender document. You would find 100 to 300 page of document. Just try to find out some vital points from that. It would take you hours. My contention is, why can't it be reduced in 10 pages? Give only the main things. What is the requirement of all that? See, Dr. Chaurasia mentioned about the solid waste management manual. When that was being made, I had tried to incorporate a model bid document also, but somehow the ministry was not interested at that point of time, because the manual was already, it was crossing 1,000 pages. So they said, don't make it more voluminous. So it didn't happen. But I would again like to say here that the tender documents must be prepared properly, because the success and the sustainability of the project, a government funded project, depends much on that tender. Otherwise, what happens? See, I have been in the government side also. What we did was, we had also prepared tenders. So what we did was 70% weightage on the finances, 30% on the technical. After my retirement, when I worked with Terry, we prepared tenders where the technical weightage was 80% and financial weightage was only 20%. So actually, in my opinion, the technical weightage should be around 60 to 70%. The rest can be financial. Because if the project is not technically, sustainable and viable in a long-term manner, yes. What is the point of having a project? It's of no use. There have been n number of projects in solid waste management or in sewage treatment plant. Give me one or two examples of projects which are seamlessly running for 10 years. You won't find any. It's very so difficult. I was seeing Pravinjit's, he had very beautiful photographs, but I saw that most of them were from outside India. Why? Because our projects, you see, our project photos should be there, but we don't have that kind of projects, which we would really be proud of. So we should be very careful about all these things. Now, so this capacity
Dr.
building.
Mazumdar, I'm so sorry to interrupt you, but
Just 2 minutes.
okay, sure.
So capacity building and planning capability. And finally, of course, and here is a challenge which I'm facing right now. I'd just like to mention to this August gathering. You see, in spite of all the documents, all the dictionaries, technical dictionaries, and all the handbooks, we do find sometimes very big challenges. Like right now, I have a challenge where there would be a gathering of 30,000 kids, okay, for 1 week. Now we have been told to make arrangement for sanitation, toilets, as well as bathing, cooking. What should we do? For toilets, yes, we can do. For the sludge, what should we do for 1 week? See, the system has to be there for 10 days, for example. What kind of investment? For 10 days, you cannot think of it. So such challenges also do come. So for waste management professionals, whether solid or liquid,
I'm still in a
there
meeting.
are
1 second.
challenges
We'll give you a
which
call.
we need to solve, and resolve. Of course, a great pleasure. But finally, I'm really very happy to be here, and I could learn a lot from this. And I really thank the organizers for involving me. Thank you very much.
Thank you so much, Dr. Mazumdar. And I think that brings our webinar to a close. I'd just like to thank the Technology Development Board for giving us this opportunity to co-host this event. And I would really like to also give a special thanks to Pravinjit, who really brought all of the speakers together and made this happen. And if there are any further questions, we can take them via email. I'd be happy to share an email address with the participants later via TDB so that if there's anything that you would like any of the speakers to address, they can do that over email. Thank you once again, everyone, for attending. But before